So a new day, the same project. This is part 5, and finally we are lucky and we have a really nice sunny winter day. So I have my two panels connected, 300 watts, and here I have my test ground. The battery is straight to the charger, and that's the panel over there. And let me make the connection and we'll start the test. This is the final test, so finally we'll see how this charger is behaving. What I have to say, the MOSFETs have been replaced, a better heatsink, a fan, just in case, temperature controlled fan, and we have this volt and watt meter over here, and we have this batteries around 8 amps or something anyway. So I'm gonna put them all to charge. The point is to see if the charger stops at 12.6 volts. That's all. If we got that limit, then we may say that the charger is working. So here we go, let's start the test. Okay, so the camera is rolling. Let's connect the batteries. So we have 10.8 volts, and now it's time to hook up the panels. There we go. And we're charging with 6.5 amps. 11.24 volts. Let's wait for the charging. So let me hook up my mobile to the USB port over here, and we have another extra charge. It's running. Yes, of course. Beautiful. 6.0 amps, and it's going pretty well for now. You see a really nice charging current. It was 6 amps a few seconds ago. That's really 60 times more speed than normally. Each minute it's a second now. As you may see, we reached 10 amps, 11 amps, 12 even, and there was no problem with heating or anything, but suddenly I realized the fan is not working. One of the wires get broke. I just fixed it and the temperature went back to, let's say, 40 degrees or something. Anyway, it was nothing to worry about, and this is nice. And there we are around 7 amps, 4, 5, and the voltage is growing, 1241 volts now. It's 1145 like hour, 1242, and slowly we can see the amps going down. The sun was up there, so it was no problem about the power. The charger is doing fine, the temperature is under control, the fan is spinning, and now we have the panel voltage 21 volts. That means the charging is pretty relaxed, so the panels are going to the original voltage, I may say. We just have a few amps, 1.2 or something, to fill the batteries. All this process starts at 10:51 or something, and it ends at 12:44. So in fact everything was around 2 hours, and it's plenty of time to fill 8.5 amps batteries. Everything is running smooth, no overcharge, no overvoltage. All I can say for now, we still have a little bit of sunshine, so the panels are pretty okay about delivering the energy. And that's the end of my test, and all I can say that finally it's working. So the charger did the job. As you may see, 8 amps, exactly how much the batteries are over here, the total capacity, I may say. It stops at 12.6 almost, and now it's just trickle charging. I don't want to say anything else but that it's working. But of course with better heatsink and with this little fan over here. I had a problem before, one of these wires get smashed or something. Anyway, this is just experimental, I may say, and it was a peak of amps. The fan is doing a great job. The final result is that the charger it's working, but not the way it was from the factory. With that iron plate, of course, it was overheating and the MOSFET get burned and all the other stuff. But now you see it's the right voltage over there, and now we have the right amps, and like I said, the sun is still shining, you can see that, and there is no BMS. That's nothing related to the lithium polymer batteries here. It's just simply the charger, the watt meter, and the batteries, not even a balance. Okay, that's it for today. Thank you very much for watching. I hope this is useful for you, and if you have any question, don't hesitate to ask. I'll do the best to have a good answer for you. Please subscribe and don't forget to have fun. Be safe. Bye bye.